Vloggerdome, the TV show.
Welcome to this 10th edition of Vloggerdome, the TV show. This episode we're going to do something a little bit different. We're going to talk physics, science, instead of philosophy. But they're really the same thing. They're both efforts to describe the truth. Philosophical subjects deal with things that are kind of immaterial, relationships and such, and physics kind of deals with the material. It's all material in the end, in the sense that relationships are created by material facts. But anyway, it's all a description of the truth. And so we have a description of our physical reality quite different from the one you might have heard of. The quantum and the bent space and the time dilation, explained with a real model instead of just obscure and abstract mathematics. There's a website and other information, posted link in the video somewhere, where further information will be provided, and this description will, it's a first edition, it'll be edited and enhanced as time passes, but hopefully I can get through it and without being too confusing. So to begin, the universe and gravity, forces, all the forces are really just one force, and they're just extensions of them. So magnetism, electricity, gravity, and the nuclear forces holding atoms together, they're all made of one thing, a pushing directional pressure that surrounds us right now. In the universe is really just made up of these bits of things, and when the bits of things are all pointing in one direction, or a group of them are pointing in one direction, we call that energetic. When they're somehow contained and their directionality is equal in all directions in the group, when they have a balance of direction, we call that matter, because it's not doing anything, it's not imbalanced in any one direction, and it's basically just a collection of these bits of energy. But the bits of energy just surround us. It's what gravity is made of, but gravity isn't what you think it is. Gravity isn't a force affecting matter, big blobs of things. Gravity is affecting the smallest bits inside of you. We can sort of see an example of that in that there's a asteroid belt that was at one time a planet, and now it's been smashed into a bunch of little different sized pieces. And those pieces still orbit just as if they were a planet, because the gravity that's holding them to the sun is exactly the same. It's affecting the little bits inside of the matter, not the big bits. It doesn't matter how big something is. It just matters that there's atoms in it, and that those atoms have the constituent parts of protons, neutrons, and electrons, which are really being affected by the force of gravity. So the idea is that these bits do nothing in and of themselves except exchange directional information. They don't get bigger or smaller. They don't move faster or slower. So think of them as little arrows, and they're moving in all directions at all times. There's a mass of them of equal pressure in the part of the universe we exist in. And they can't do anything like get hot or get smaller or bigger. All they do in interactions is exchange directional information. One will be going one way, one will be going another way. They'll intersect, and one will still be going that way, and one will still be going that way, as if nothing happened. But something would happen if you consider that one is changing its direction. Even though the end result is the same, it's not quite the same. So this is the first almost paradox of reality, is that we have this circumstance where there's an interaction that can be perceived as being invisible, essentially, or visible, dramatic. So something changes its direction by 90 degrees, or nothing really happened. And that's the mechanism of the universe, the function, is that really it's just directional information being exchanged once things get established in a circumstance. So think of it as if you're in this sea of things going in all kinds of directions, the only ones that would be relevant are the ones that would hit you. So if you took out of the image all the ones that didn't hit you, weren't going to interact with you, you would see that all the ones that will are coming in straight lines from some location. And like light beams from stars, they're just coming at you in a straight line, and almost like the opposite of how you think of a light bulb radiating electricity or light. You can think of it as the effect of the force essentially on you is just the arrows that are going to hit you are always going to be coming from somewhere in a straight line. And then you get the idea of this idea of the pressure becomes kind of real to anything that has a location. So anything that has a specific location, it would always have pressure from the things that will interact from it, and that pressure would be even in all three dimensions. So the idea of gravity created by this force is basically a shadowing effect, that the little bits inside of the atom can block some percentage of this pressure, in the sense that it interacts with it and directional information is exchanged. And when that takes place, there's a shadowing effect. It's this inverse square rule of gravity, which means that as you get as you double the distance, the force would be 1/4, and vice versa. If you half the distance, the force becomes 4 times as strong. And that's how gravity, magnetism, and electricity work. And that is basically a force reflective of straight line vector force application. So any force that would be applied by something moving in straight line vectors would automatically create this effect. And so it provides a intuitive or common sense kind of understanding that this is what gravity is doing. It matches this idea of straight line force, that some kind of photon or some kind of particle force would be creating gravity, magnetism, and electricity, in the sense that these qualities of these forces, these invisible interactions that we see, do have as an effect, they match the mathematics of gravity. So the idea of this shadow is, get back to that, is that you created a lack of pressure in between something. If some element of a force from the exterior is blocked, that means that there's going to be more force on each other from what's being shadowed. So this item, there's 2 items, one item is going to be shadowed by the other from the external force going one way, and the other item is going to shadow the force coming from the other direction, and there's going to be an obligation for the items to be migrated towards each other, in the sense that their internal structure will be changed, their directional movement will be changed, and they will gain velocity towards each other by obligation of the pressure. So to understand it further, so as gravity's coming down through you, it's going through you, and directional information is being exchanged. There's no particles absorbed or destroyed. They just leave in a different direction. So a tiny percentage of all the stuff coming down on you, raining on you from all directions at any one moment, is being blocked by your structure, and the same from the Earth. The Earth is blocking a bunch of the arrows coming from below you, coming up, and a percentage of those arrows. And so now you have more arrows coming down than you have going up, which are forcing the 2 into each other. And it's not because they've collected the arrows, like I said, it's just that they've exchanged the directional information, which means that on net, if you were to think of me as being just a collection of arrows, when I'm in gravity, what's happening is that more of my arrows are exchanging for directional information in a certain direction. So there's more interactions in that direction, which means more of my arrows, there's a net imbalance, and it only has to be a tiny imbalance. So we're talking 1 in a million that now gains this, exchanges this direction for the down direction. And so I have a few more arrows going down inside of me than I have arrows going up, which means in net I move down. Now the Earth is in my way, but I'm still banging into it and it's still pushing back. So in theory, I'm still, the atoms inside of me, the molecules, are all bouncing essentially. And so they're still moving. They're just moving up and down a lot as the Earth rotates. So this is why the GPS satellites have to be adjusted, because in theory they're supposed to run slower, the clocks in the GPS satellites, because they're further out in space and they're moving very fast. But the practical fact is that because we're in a heavier gravity than those satellites, and we are effectively bouncing up and down, our clocks run slower, because we're traveling a lot more distance, and velocity is distance, time is distance, effectively. So if you have to travel more distance in a set amount of time, you must have a higher velocity to do it. And so essentially we're moving faster than the satellites going 10,000 miles a minute or an hour. I'm not sure which one, doesn't matter. The point is we're going faster, even though it doesn't look like we're going faster, because we're taking a longer route, because we're bouncing more. The satellites are only bouncing like this because they're in a weaker gravity. We're in a stronger gravity, so we're bouncing much faster. Anyway, okay, so this idea of the directional information, I guess we'll go through it just to be sure of it. So there is no exchange of energy. There's just an exchange of directional information, and it can come in. You can look at it two different ways. You can look at it as interactions are invisible, or interactions are dramatic, depending on just how you perceive it. And that is an interesting fact. Alright, so to get to the basic mechanics of what holds an atom together, what holds the electron together, what holds the proton and neutron together. So these are just elemental parts, and they all have gravitational, magnetic, and electrical properties. And these are all made out of these arrows, but the arrows have different character that I'll later explain how it's adding to the strength of the forces between atoms that are different than the forces between suns and Earth, because they do have these electrical and magnetic components that are really the same force. It's the same arrows, it's just the arrows have a character, and that a subtle character, which is called polarization, but I'll get to that. So the thing to understand, okay, we'll do orbits first, that you can have also two kinds of orbits. So if you can understand this, if you get the basic idea of this idea of the pushing force, because you're blocking, you're shielding something from arrows, you can have two kinds of gravitational arrangements. One where there's a stationary, relatively speaking, object in the middle, and something that rotates around the shadow created by that stationary object. A kind of gravity we don't see manifested, or a kind of orbit we don't see manifested in the solar system, but a theoretically just as valid gravity, would be two objects moving around each other. So they're both moving, and they just have orbits that are opposite each other. So they block each other all the time, because they just keep rotating at exactly the same speed and always remain opposite. So theoretically our solar system could still function without the sun if you just brought everything closer together and you had an anti-Earth and an anti-Venus and an anti-Mars that was exactly opposite in an orbit, and they would still then be able to orbit each other based on shielding gravity constantly by being in the same orbital, having the same orbital momentum. And that's important probably in the structure of atomic pieces like electrons. Electrons may not have any nuclear bits, they're just bits that are rotating around each other effectively. Alright, so back to the directional idea, and how you can understand how it can create these orbits, these arrangements between the arrows. So if arrows get into an arrangement, it's like the Earth, for example. In every item that has in the solar system has to be at a certain speed for its size, its mass, size, for it to maintain its orbit. If it goes faster, it'll go too fast and escape the gravity of the sun. If it goes slower, the orbit will degrade and it'll fall into the sun. And the same is likely true for these arrows. To be kept into some sort of arrangement, it ends up being a kind of perfect arrangement where they're going the right speed, which is always the speed of light, in the right mass, amount of them, in the right size orbit, let's just say, to be able to maintain that orbit. So in the solar system, you could change something's ability to stay in orbit by just changing how wide the orbit is. If you force the Earth to go into a wider orbit, it will escape the sun's gravity, and if you force it into a narrower orbit, well, it's probably the opposite, right? Okay, yeah, it'll fall into the sun. Something like that. Yeah, well, either way, you can get it. You have to have the right speed for the orbit you're in. And this applies also to these nuclear forces. So if you can imagine these arrows exchanging directional information, and you think of it right about things coming in at sort of even pressure, we have to simplify it just because it's, there's zillions of them. I mean, you can't draw 10,000 of them. So you just simplify it as understanding there's a net balance of pressure. And if you understand it that way, you can understand how things could be in arrangements where that net balance just keeps them in a box, so to speak. And that you can just take that box a step further and call it a circle if there's enough little facets on the box. And so you can imagine if it's made up of enough little bits, it can look like a circle, but it's really just a bunch of arrows going a direction, and that they keep getting pushed effectively by the pressure being applied. Alright, so once you get that's the mechanism that creates an orbit, then you can understand that orbits can have different shapes, or they can be eccentric. The orbits of the planets are all ellipses. They're all a little bit out of round, and this phenomenon of being out of round is likely going to be more exaggerated, even more of a problem, quote unquote, in atomic structure because of the graininess of the force application. It isn't as fine. Gravity is it's like the pixels in an image. If I give you an image of something with only 10 color dots, you're not going to be able to resolve it. But if I give 1,000,000 color dots, you'll be able to see the image. Well, it's that kind of effect on the atomic level. These forces, or these arrows, have a much stronger emphasis. Each little arrow is very important in terms of maintaining something's structure. And so you can understand that once you have this idea of say a perfect circle of arrows circling each other, and I add to that an influence in one direction, I add another arrow going one specific way, that there will be nothing in the structure to account for that. If I don't change any of these external arrows, what I've essentially or effectively done is created an arrow that's just going to keep repeating itself, and the object will just start rolling in a direction. Now you could also understand that as it just ending up being something that once you induce an extra bit in one direction, that direction could also end up rotating by the same kind of force. So if it then just end up being a wobble that doesn't go anywhere, a wobble that ends up being circular. So it's almost like the dimensionality of this idea of having circles inside of circles inside of circles, and then you get into the big universe kind of orbits. They're all just complexities of the same idea, and a different, much different size or resolution of just the grain of the thing itself. The thing is made out of a kind of sand, and if you're looking at the image from 5 miles away, you don't see the sand. But if you get a foot away, you're going to see the sand. And that's really the only difference, that there is a difference in property, based on how deep you're going, how to the real source of the sand, the real beach of the universe. So anyway, so you can have two different kinds of this arrangement, where something can be wobbling in space, or it can be moving in a direction because of that same imbalance. So the imbalance can cause two kinds of configurations. One that's a wobble, and one that has a direction. If it has a direction, we tend to call that velocity, where the stuff inside of you isn't wobbling in place, it's wobbling it more in one direction than any other direction. And that's essentially how you acquire velocity. And it's the reason, like, once you acquire velocity, once you are moving, something needs to change that wobble inside of you. Something needs to add arrows to counterbalance the imbalance in a direction, for you to stop moving. And that's the nature of velocity. So I don't know if there's anything else I need to do on that one for now. I guess just the analogy is just to understand the size differences. I heard it said that the Earth is to an apple, so an apple is to the Earth as an atom is to an apple. And you could likely do something like, a quanta, an arrow, is to an atom, kind of thing. It's probably not that grainy, but there is this idea of, recognizing the scale difference. So I can tell you that quanta are small, but it's really hard to illustrate it. So dealing with photons will be maybe a way of doing that, because you can understand that the spectrum of what we call the electromagnetic spectrum, I'm claiming there is no electromagnetic component at all, that photons, light and cosmic rays and radio waves are just made out of these arrows. They're just arrows with a specific frequency. So the arrows that make up gravity don't come at regular intervals. They don't have some partner who's exactly a certain distance away going exactly the same direction. And where photons of light, for example, are basically arrows in the sea of arrows that have a pattern that repeats, a pattern of distance. And all they really need to be recognized as a photon is to have a pair of them separated by a distance. That's called the period, but it's effectively the same as the wavelength or the frequency. So when you hear about the frequency of light, it's just about how the distance between the photons, the little bits, the real little bits, the arrows, the quanta. So the distance between the quanta, the arrows, is what we call frequency. And so things that are coming slower, which means they're further away from each other, are lower on the spectrum, and things that are really close to each other, and so there's more of them that can hit you in a given amount of time, we call, high energy radiation. And now, so the difference between red light and blue light is the blue light is going about twice as fast as the red light is. And so there's twice as much energy, quote unquote, per second available if they were coming at a constant stream at their maximum amount, their equal distribution. And so that's how you get different energy levels. Now, a way of understanding further, to understand that the relationship between these discrete bits is so precise that things like radio waves there can be miles between the little bits. So between the little bits that are arrows, there can be miles, literally. Now, miles of difference. And so you can kind of think of that as it going by you at some, one photon goes by, and then one 3 miles away goes by. And the trick is the speed of light is so fast, 168,000 miles a second, that actually, even when they're 3 miles apart, well, let's say a mile apart, even when they're 1 mile apart, these little tiny bits, as they stream by, 168,000 of them will pass you in 1 second. So in that 1 second, 168,000 of these things went flying by, if it was a very wideband radio. So that's the way to kind of understand this difference. And at the other extreme, the cosmic ray, I can't, any imagination you try to apply to even understanding how many went by in 1 second would be probably a waste of your time, because your imagination would probably still need to times the speed of light, square it or something, to really get just the volume of stuff that's all around us. This little container right here has universes, in terms of, if you took all this stuff, if you could take every speck that we could see with a telescope, every single dot of anything that we could identify in the universe, there would be more in just this, of these arrows, of this stuff moving. So the one feature of light, to get to light, is that it has this idea of polarization, which is it has a shape. It doesn't really matter whether it's a disc or a stick or even a domino flying, a flat domino you could just think of. It's coming at you with a direction. It has an orientation as it moves, a length and a width, and so it can be in that orientation. We call that polarization, and it's a pretty well established fact that if you make like a prison bars, you can think of it as, that if you try to throw a frisbee through the prison bars flat, it won't go through, but if you throw it straight up, it'll go through the prison bars. Well, it's the same kind of idea with polarization of these quanta. This applies both to light and gravity, which are both made out of this same arrow, this quanta. And this is what's responsible for magnetism. So, as these things fly through us, if we were, say, a magnet, had a top and a bottom, a north and a south, you could understand that the stuff that's going through us, the gravity, and let's say 99% of it never is effective, in the sense that nothing inside of us exchanges directional information, because most of the atoms are empty space. There's nothing in them. And so you have to go through an awful lot of them before you have a 50-50 chance of hitting something. And so there's not a great chance. So most of the stuff in the universe goes right through us, and it's only a tiny percentage changes that we're talking about. And that's what I'm sort of trying to illustrate, is that you have to kind of understand on this level, you only need a tiny bit to change the function. And what we call regular velocities, we think it's going fast if you're going 50,000 miles a minute or an hour, right? 50,000 miles an hour seems really fast. 50,000 miles a minute is preposterously fast, 60 times that speed. And then if you get to this, 50,000 miles a second, you're still only 1/4 of the speed of light. So that's how fast they're, 1/3 of the speed of light. So that's how you have to kind of understand that when we talk about our velocities are nothing by comparison to the speed of light, which all these little bits are moving. So even if you had 1,000,000 of these little bits moving in all kinds of directions, you add one arrow going in a direction, and that will add up to, so 1 in 1,000,000 change probably adds up to 50 miles an hour in terms of the rotational spin or orbit change that will be created. So we think of it as a lot of velocity, but it's only a minor amount of velocity that's theoretically possible, just because light is so fast, just because these quanta, the speed of light, is so fast. It's really the speed of quanta. So it's these 1 bits in the universe, these arrows, they go the speed of light, they don't exchange any material anything except directional information, to reiterate. So anyway, back to the magnetism. So this stuff is coming into you, and it's of all different orientations, polarizations. And what effectively a magnet's doing is, even the stuff that doesn't hit something, it's changing its polarization. So it's influencing it from this to this, or from this to this. It's elevating or changing its orientation as polarized. So it's not changing anything material about it except just changing its orientation, which doesn't require any force or application of energy to do. It just requires structure. And so the structure of magnetic materials are such, the arrangement of the atoms are such, that anything that goes through, any quanta that goes through that arrangement, those bars, like the jail cell, you can think of it like a frisbee. If a frisbee went in at an angle and it hit just the edge of the bars, it would be straightened. And that's a fact of polarization, is that light can be bent into a new polarization. And likewise, these gravitons, or these gravity arrows, can have their orientation likewise changed without any consumption or release of energy. So anyway, the gravity comes into these magnetic items. So we have a north and a south pole, let's say, and gravity is coming in from all directions. So it's just besides the regular gravity that's pushing you down. Now this is just the extra gravity. And in a magnet, what's happening is the gravity coming in, say, on one side, the forces, the arrows, are converted to, when they leave, the odds are, by proportion, some significant number of them, more significant than the number used by gravity. They have a higher probability that when they come out, they're going to be polarized in one direction. So the top part of my body, you could say, is shooting out graviton, or gravity, in this direction, and the bottom would be shooting them out in this direction. And that simple change provides all the mechanism you need to create imbalances in pressure, in the sense that you could be more likely to interact, to have a directional change with ones that are in a certain polarization. So depending on your material structure, ones of a certain polarization will have more of an effect on you than the other one, and you will more likely absorb directional information from that item. So the item, so you can think of it as the force will go in this way at you, and it will leave in that direction, and what will change is some arrow inside of you will now be going that way. So you'll absorb direction, and that's what the magnets are doing. So it's a way of magnifying gravity, in a sense. You can think of polarization as a way of just magnifying the significance, the reactivity of the gravitational force, making it stronger, or in the inverse case, weaker. So there'd be gravity that would be invisible to, polarization that has less effect, and polarization that has more effect in terms of exchanging directional information. And so you can understand that that would create a magnified attractive force when the two poles are opposite each other, and a magnified repulsion of force when the two poles were facing each other. The two things are the same, producing the same thing that they're both more sensitive to, would force a greater pressure between them and force them apart. Whereas if they were both creating the polarization that they're invisible to, then they're going to end up being pushed together. And so that's magnetism. And electricity is basically, in theory, there's two phases to the polarization. The first 1/4 to the peak would be electricity. The second quarter to the base would be magnetism, and that's why the two induce each other, is because they're really just the two halves of the same thing. It's basically, you can call it magnetism or electromagnetism, but it's basically one thing. It just has to do with the phase, or the whether it's, you know, from here up or from here down, is the difference. So I won't go too much into that, because that part's, you know, you have to start dealing with a lot of math and in terms of the induction of these two forces, and the vector lines get kind of complicated. But you can sort of imagine that what's really happening with the field lines around a magnet, for example, is those field lines are a representation. They're not a real thing. They're just a representation of where there's vectors from the polarized this way and the polarized that way, where they intersect each other coming from the two poles, the two sides of the magnet. And where those two sides intersect, the neutral point, or the impetus, is based on the angle that something with no momentum would move parallel to that point. And so that's basically when you see a field line, what it really is representing is a bunch of little lines going off parallel. So it's better to think of those field lines as little flat facets connected to each other, and the facet just represents that the space is indicate the pressure would create a movement parallel to that line, straight out. But the force is really just a bunch of straight line quanta moving the speed of light. Magnets are essentially radiating an intensity like a light bulb. They're radiating in straight lines a bunch of this force, and it just happens that the force they're radiating from the top half of the magnet is different than the force they're radiating from the bottom half in the sense of its polarization, and that creates imbalances when it interacts with other items that are capable of reacting to different polarizations in different ways. So the orientation of most of their atomic structure, most of the atoms are going this way instead of this way, might be an explanation for why certain polarizations would be more effective or less effective on the general matter. And that's another thing to understand, is the matter we're made of the atoms are again just bits inside of something. So you can think of like the electron is made of orbiting things, the proton is made of orbiting things, the neutron is made of orbiting things. Those things in turn are orbiting. The atoms themselves are orbiting each other. It gets very complicated in terms of the dynamics of the movement of all these items. But there can be structures where, when there's a molecular bond, when things are bound to each other, they're not really moving around each other. The electrons are effectively doing the movement, combining them, where they're moving through, cycling through each part of that orbit, tying those two things together. So the thing can still be spinning, but in rigid, hard matter, most of the atoms have an orientation that may be very rigid in terms of the if it was to think of it as a solar system, it wouldn't be just completely wobbling. It would have a rigid connection to a place in space, and but there's still a lot of action around it in terms of its entire exterior shell is constantly in flux with the other solar systems it's connected to, or bound to. And so instead of rotating, its its exterior planets are creating a rotation around it, so the center bits can be more stable, less vibrations, less movement, and the exterior bits can be doing all the moving. Trying a slightly different style of explanation, I thought I would talk through some of the features of this theory in terms of how it would affect, from the beginning, the nuclear forces. So I suppose the first thing to understand is that the pieces, all the things that they call particles now, electrons are called particles, but they're actually these quanta caught up in some sort of rotations, very small, very distant from the nucleus, and the nucleus of the atom has protons and neutrons, and they're denser, but they're also individual swirls of these quanta, so they're not discrete parts, they're not the quanta themselves. They're made up of something that's already a thing, matter, and they have already a gravity, they're already causing a change in the arrows as they go through them, there's an effect. And the effects inside a nucleus is the first thing, I mean atoms is the first thing you got to understand too, is the bits are moving the speed of light, and the distances in atoms will change. I mean, light speed is such that things that there won't be instantaneous effects because of the speed of light. In atoms, it's going to matter, and so the effects of something blocking will not be where you would think it would be, because it will take time for it to get there. So the force has a real delay that's real on the atomic scale, where we don't recognize it just because we're so much larger, and so those delays aren't realized in any kind of visual or way we can see or appreciate. So basically the atom's made of these three things. There's more parts, they say, but let's just say it's these three things. There can be lots of more parts. And they're just doing the same thing as I described before, you know, these magnetic effects where they're creating polarized gravitons and causing attraction and repulsion between each other, and still the basic effect of gravity itself. And all these effects are also have this little bit of delay because of the speed of light built into them. And this is what's holding the parts in an arrangement. So these arrows come in and they always go out. They don't get captured. So magnetism, electricity, and gravity are not captured quanta, where photons, light, it ends up being part of the mechanism. So photons are how these little parts get bigger and smaller. They gain mass. So gaining mass is different than being affected by a force. And the force effects are always, whatever comes in, something has to go out. And what's coming in is one kind of direction, and what's going out is another kind of direction. And that's basically all these machines do, is collect direction. So that's basically the function of matter. It's just to collect directional information. And so there's no energy transfer. There's just a change in the disposition of the energy, and whether it's going this way or whether it's going this way or whether it's circling it perfectly and staying in one position. I'm back. Anyway, interruption. So this would, in combining chemistry, to taking this to the chemical level of these, once you establish these arrangements of these nuclear parts, the proton, which is positively charged, the neutron, which is some other charge, and the electron, which is negatively charged, which really means you all have this different polarization. One is producing this, one's producing this, one's producing this, and depending on what you're producing in terms of a polarization will also affect what you're affected by and create all kinds of internal tugging forces. Now when atoms combine with other atoms and they talk about shared electrons, what's really happening is that there's a net charge of the atom itself, and that charge is what's holding the atoms together. So that's probably more to do with the protons and the neutrons being magnetically, electrically, statically, and gravitationally connected to the other atom, in the sense that it has a net arrow. It has a net directional arrow. The directional arrow ends up being in the direction of the other thing because of this gravity. So there's always a net balance of arrows around something, and that net balance will induce acceleration, and that induced acceleration will create a velocity, and that velocity will create combination often, or connection. And there's obviously could be pressures that would be involved in terms of, you would have to say two atoms were moving separate velocities acquired from other places, and they were to bang into each other. Depending on their velocity, you could sort of understand that there would be internal bounds that get hit, but there might be an external magnetism that they have to push through. So they end up having to go through one force, and then some other force will bond them. And that has, you know, a lot to do with how atoms get bound, that once they have a breakthrough pressure, and once they go through this breakthrough pressure, then they're able to remain consistently connected to each other. They end up in a stable relationship. So that's really all you were talking about, is a stable relationship of the movements collectively and the balance of the arrows. And so stationary matter, what appears to be stationary matter, it's always got some acceleration somewhere, as far as we know it, um, is just matter that's trapped in arrangements that are stable, and that have no net imbalance of arrows. But right now I have an imbalance of arrows as as I'm moving with the Earth, and I'm also have this imbalance created by gravity, which just keeps pushing me down, pushing me up. So constantly, every 10,000 times a second, a million times a second, I'm being vibrated. Too many up arrows, too many down arrows, too many up arrows, too many down arrows, constantly. And this is the forces that are holding atoms together. Alright, adding a little bit on acceleration. So the idea is that things end up moving in the world and at all levels of material structure, and that movement is just an imbalance in this collection of things moving in a straight line and conforming to some pattern that is maintainable. So it's hard to analogize, but you can just imagine wave ripples in water or some other manifestation where it's the same substance, it's just in a different configuration at different places. And that's kind of in this whole sea of little bits moving. What's really happened is that patterns form, and if the pattern is the right pattern, it will be maintained by the pressure. The pressure will keep maintaining it based on the rules of these kinetic interactions between these little bits. And so you can have a lot of complexity that's just hidden inside of the movement, and it just happens to be a certain kind of pattern that's just repeatable. The pattern keeps repeating because the pressure doesn't change it, and doesn't change it in a way that breaks it, that makes it go back into chaos. So it stays in some sort of filtered configuration. So with velocity, is you have this idea of something orbiting, and it acquires more direction in a direction. It acquires more stuff going one way, and then it ends up moving in that way, all of them, just because of that one bit of stuff. It changes the balance between them. The pressures are migrated through every interaction, and every interaction just moves everything. So when I move, all the parts have to move. The little nuclear bits, every single one of them has to move with me, and they move because the arrangement, the pattern shifts, and as the pattern shifts, the bits have to shift with it, because the change is now, the pressure changes, and that pressure change goes to the new location, and that's where it will be maintained. So with the acceleration, what's happening is some arrow comes in, and it changes an arrow. So one arrow is going this way in the pattern, an arrow comes in, and it changes that direction to this direction, and it loses an arrow going the other way. So the output is always out. And when the stuff comes in, I'm always radiating it back out again. So it's in a sense changes direction. It bounces off. But again, that's the duality here, is that you can perceive it as being everything just goes right through. And the two outcomes are the same, but the real point is that this imbalance, or this structure, is maintained. So when something's accelerated, there's a change in, so if there was 5 arrows going this way, and now there's 6 arrows going this way, and there's only 5 arrows going the opposite way in the structure, then there'll be a net migration in the direction of the imbalance. So any imbalance just creates an impetus, a tendency over time for the entire structure that's connected to that thing through this pressure, for that whole pressure field to migrate in the direction of that imbalance. And that's basically the nature of velocity, is just the taking of that pressure and migrating it in a direction based on creating a net product. So again, it's always the same amount of energy, gravitons, quanta, arrows, things moving the speed of light in a straight line direction. There's a balance change, it creates a balance change. So if there's more coming in because of gravity on some side is being blocked, arrows are being blocked from one side, then more are coming from one side, it creates an imbalance, creates an acceleration. So you're accelerating all the time by gravity And if you didn't hit the Earth, you would be moving faster and faster and faster and faster, because you keep gaining more arrows. More arrows going this way would be converted to arrows going this way inside of you, and the net migration of all your force balance would end up, all the force balance would have to move in that direction. So all that's balancing, connecting each one of my atoms to each other, as the arrow goes in, that arrow's directional information is essentially translated as a little tiny, it's essentially converted into a little tiny bit of movement all in that direction, based on how the orbits will all change. One little tooth in the jagged orbit will be changed in the direction of the change. Okay. Now a little bit on time dilation. This is an important one. So yes, by this theory, Einstein was, his relativity theories, both general and special, are wrong. And space doesn't bend time. Time is changed. How time passes, the clocks change, their function changes based on velocity, and all velocities are absolute. So once you've been accelerated, once you've had a bunch of your arrows changed from, say, this direction to this direction, so now you have a net imbalance of, say, 10 arrows, so you have 10 more arrows going this way than you have this way, and you have some sort of velocity. The implications of that are that these orbits that are being created have to travel more distance. So you can use the analogy that if you were doing a dance step, and I told you to dance as quickly as you can, and then I asked you to move to the right or to the left as you were dancing, you would realize that you can't dance as fast, because you have to keep wasting a step to move in a direction. You're using up one of your steps. You're using up a piece of time to go in a direction to the right, and so you can't be dancing as quickly. And that's sort of happening inside of the atom. So its own metabolism has changed. So when the atom starts gaining a bunch of directional information, a bunch of extra arrows in one direction, yes, it's just a change in the arrows that already existed, but that sort of indicates that now orbits will be much larger. So as the orbits change from, say, something sort of round, and it's changed to something sort of oblong, you can understand that the area would be different, but also that diameter will be different. And so there's more distance that has to be traveled, and distance equals time. So time ends up changing in the sense is that all the functions of the atom that are dependent on orbits, which would be the absorption of light and different things that take place, all those functions are effectively slowed down. So if it was a clock or something, all the atomic bits are slowing down in terms of their own metabolism, which is creating a kind of time dilation. Now this only gets serious about like real seconds or minutes of time at incredibly fast speed. So you have to go really, really fast to start having any real effect of this lengthening of the amount of time it takes to do an orbit inside of an atom, based on the fact that the orbit's gotten longer because it's gotten stretched out by this idea that it has to move in a direction. And so it's not something that affects common matter. I mean, this pencil could be moving, but it's not really aging much slower than this one. But if I could move it at realistically very fast, 50,000 miles a second or something, then this pencil would age slower, in the sense that the atoms would degrade and metabolize and do their orbits and do their interaction at a slower rate, because everything has been slowed down effectively in terms of how it interacts with the rest of the world. How its own aging process. Atoms do age as they have orbits that's over time, over thousands of years, that would degrade because they're slight changes, slight irregularities. So anyway, as a final bit, I'd like to say a little bit about the two-slit experiment. It's very famous in physics, kind of settled the issue of whether light was a particle or a wave. I think settled it in the wrong direction. So there's this idea that what exactly is a photon? And because of this two-slit experiment, it was assumed it must have some sort of properties because it behaved very erratically, and so began quantum mechanics as a theory of structure. And so the photon was assumed to have this capacity to be magnetic and electric, and for it to display fantastic phenomenon, to be two places at once, do all kinds of things, based on this idea that it projected some kind of forward wave in front of it and sensed its environment and then behaved accordingly. But anyway, I believe I have an explanation for that consistent with this entire theory. But also this kind of was the reason why I started investigating some of this physics, is because it just didn't sound plausible that all that structure could be in something we know to be pretty simple in every other experiment. So anyway, the idea is that when you use a single slit and you project light through it, there is some diffraction. And you see that some of the light goes straight and some of the light is bent, sort of like a prism in effect. And then when you do this two-slit experiment, though, you get this fantastic phenomenon where there's a whole bunch of interference, where there's a bunch of peaks and valleys where the light goes all in one place and goes none, and then some, and then none, and it's been left sort of unexplained as anything other than like wave mechanics, where waves would interfere with each other and have what are called constructive and destructive interference. Now, the idea of a photon destructively interfering doesn't make any sense because it violates conservation of energy rules. So anyway, the idea is that you shoot this light through the two slits and you get this different pattern. It always should be understood that this original experiment was done in the 1800s, and all of this wave theory was based on it, and even Einstein's relativity theories were based on it. All of physics has been based on it, and it's kind of a wrong assumption, wrong explanation for the phenomenon. So the idea that the photons were interfering with themselves, it's not really the photons, it's the electrons that they interact with that gave the photons the character they displayed, or create the pattern essentially. So in the two-slit experiment, you have a light source and you go through a small aperture that spreads the light out. So you have a peak amount of light in the center, and then it falls off as you go away from that peak. And that's traditionally how the experiment's done. And so in the one-slit experiment, you get, it's kind of just the light goes straight through, and only a small percentage interacts with the slit material. In the two-slit experiment, you have the opposite effect, where the most intense light is blocked by the impediment in the middle, and the leftover intensity of the light, the strongest light left over, goes right next to the slit material. So if the slit material is radiating any kind of force, it could interact with those photons and cause diffraction, so you'd have more diffraction. And so explains, in my opinion, the fact that you have a more intense pattern created in the two-slit experiment. It's basically because the matter of the slits is creating, as all matter does. The surface of my skin right now is bubbling with electrons and ions and different nuclear bits. They're flying off and being pulled back in by magnetism, static electricity, and gravity. And those forces keep pushing them out and pushing them back in again. And the light interacts with electrons exclusively, as far as we know. And so they're hitting those electrons, and that's what's causing the diffraction, because they're being reflected at an obscure angle because of the momentum of the particles as they hit each other. The directional information that's exchanged is not as precise as this interaction, because the orbits of the electrons create a change in what goes in and what comes out, has an obtuse angle instead of the standard 90-degree angle. So anyway, the idea is that next to the surface of something, if you travel through there, you'll hit particles, and those particles will create a diffraction. It's a phenomenon seen in lensing in the universe. Einstein described, he blamed it on gravity, and it's not really gravity. The lensing in the cosmos is created because there's a huge, like around the sun, there's a huge corona, a bunch of nuclear bits that fly off and then are pulled back in by the gravity. And it's those bits that the light is hitting, and that's what's causing the diffraction.